Welcome to our talk, Run Your High-Performance Database Workloads on Any Cloud with AlloyDB, or what I wanted to call it. What is AlloyDB? Why is it cool? Why should I care? If this isn't the talk that you thought it was, hang around anyway. Yeah. We'll hopefully be at least mildly entertaining. And we'll tell you about some really cool database product that we've got coming up, AlloyDB, which, as of today, or yesterday, has moved from tech preview over to public preview. So it's even more available to play with. Who are we? I am Gabe Weiss. I am a developer advocate for Google Cloud, specializing in database and infrastructure. And my two friends on stage, Kevin.
I'm Kevin Jernigan. I lead the product team for AlloyDB Omni.
And I'm Simon Pane. I'm a consultant from a company called Pythian, and we help customers with all sorts of cloud and database needs.
So now you know who we are. Who are you? Well, so for today, our agenda, this is what I wanted to do, demo, because I like doing demos.
And that's why I'm here.
And that's why Simon's here. We brought him on stage to do the demos. And then they said, no, you probably need to actually talk about the product a little bit. So instead, this is what we're going to do. We've moved through the introduction phase. We're going to do a little bit of what is AlloyDB, our cloud version, so you can kind of wrap your head around the product in general and why the downloadable version is cool. We will go into talking about the downloadable version, AlloyDB Omni. We'll walk through a couple of use cases. We'll do some demos, live demos in here. With the Moscone internet, we'll see how it goes. We'll pray to the demo gods. Then we're going to skip the next part, and then I will wrap up. So now that we have covered that, I would like to know who you all are. First, I'd like to kind of get a pulse from the audience. How many of you consider yourselves like application developers, software engineers, people hands-on keyboard? Nice. You're my people. I love you all. Thank you for being here. Do we have any DBAs? I'm seeing some of the same hands. Cool. What about like IT decision makers, the people that decide on your stack? Do you all do everything? So startups, how many are from startups? Some of the same hands, yep, good, okay. How about embedded system designers? I see one kinda, all right. This is probably not the right talk, but stick around anyway, because we'll keep you entertained. So what actually is OmniDB? It's a product. Did you know that Google is actually shipping a product? It's not a service. We usually work in services in the cloud, right? All of our standard applications, we've got VMs, we've got serverless. All of those are things that we're running. Now we're shipping a product, something that you all will run. AlloyDB Omni is a proper product. It's got release notes and like the README in the package when you download it. It's cool. So there's a lot of differences between like what is a product versus a service, and I kind of touched on it. A service is something that we run. We take care of it. We manage it. We cover the SLA. We cover maintenance. If it goes down, we're the ones that are on the hook for it. Product, you all get to run. There's some good and the bad in there. Obviously, like, we're covering all of the management of the thing, but that also means that we restrict it in certain ways. So one of the nice things about a product is you all get to own it. You get to do what you need to it. So if you need it working on premises, cool, run it on premises. If you've got very specific requirements around containment, air gapping, we now have a product that you can do that with all the power of AlloyDB. So what is AlloyDB? To understand the product that we've launched, I want to just really quick, how many of you actually went to the AlloyDB session that was up yesterday, or the main session from yesterday? It looks like about half of you. Okay, so I'll cover some stuff anyway, but they went into way more detail about AlloyDB than I'm going to. I'm going to touch on a lot of the points that I really care about and that I feel strongly about it from the development, from the kind of user standpoint of what's important to me. So AlloyDB itself, just so that we get the baseline out of the way, it is a PostgreSQL-compatible database. And not just a database engine, it has a lot of stuff around it. It covers things like the ability to spin up read pools for you, all the manageability around that. It's got a lot of extra magic on top of Postgres that we've built into it around things like performance, around, all that good stuff. So all of the management that you get from a Google Cloud service, things like automated backups, all of the data encryption in transit at rest, all of that stuff Google Cloud handles for you. Curated list of extensions, like I said, part of having a service means that we restrict things a little bit. So on extensions, everyone loves Postgres extensions. That's kind of what we live and breathe on if we use Postgres. Certain extensions do potentially really awful things for your database. With a managed service, we can't let you have that full freedom because we are beholden to an SLA to make sure that it's available. So there are certain extensions that we hold back because we know that the likelihood of it destabilizing your database is there. So the cloud AlloyDB, we don't let you have all of those extensions. So having said that, I want to walk through a couple of what I consider the real highlights of AlloyDB for me. First up is performance. AlloyDB is 4 times faster than Postgres out of the box. For certain types of analytical queries, it's up to 100 times X. So how did we actually do that? First, we control end-to-end hardware. We can specialize the software specifically and optimize for the hardware that we've got. There are certain other companies that do the same thing, like they don't let you put your stuff on other hardware, Apple. So they are, and we are able to optimize performance specifically for the hardware that we know we've got. So we can make software changes to take advantage of that. The columnar engine is the core part of where the performance comes for these analytical queries. We have a separate caching system that we've added to Postgres that instead of storing as like the buffer cache does in a row format, changes it to a columnar format. That optimizes certain types of queries. So if you're doing aggregate queries, give me everything with a couple of predicates where my price is over $100 and I only want Tuesdays. Any of those kinds of queries. A columnar format optimizes for those kinds, so you can do analytical queries in AlloyDB faster and more efficiently than you can on out-of-the-box Postgres. Then we've got real-time business insights. Who knows what real-time business insights actually means? Me neither. I got a couple of, so sales? Yeah, there you go. So I stole some of these from our sales guys. Real-time business insights, to me, means 2 different things. If you ask a sales guy, they're going to say that this is because you can actually, what I was talking about, these analytical queries. I want to get information out of my data. That's real-time business insight. I think of it more of, I want to see what is going on with my database. I don't want to have to set up a bunch of like IT folks staring at a screen, checking my CPU utilization. Is this query like out of control? What's going on? Part of the advantage of a managed system is within our console, you have those tools built in. So I know what the CPU utilization is of my AlloyDB instances by going to the cloud console, and I can see it. For me, that's like real-time business insights, is knowing what's up with my database without me having to build that plumbing. So that's that one. SLAs, this is another advantage of having a managed service. We guarantee that it's up. AlloyDB guarantees 99.9949s of availability. That's like, what, 20 minutes of downtime a month? I think, is that what that one works out to? I forget the math.
Something less.
I think it's
4.
4 minutes a month? Thank you. So 4 minutes a month is it. Now, something with AlloyDB that is new to that database compared to other SLAs, that includes maintenance. So anytime that we need to take your instances down to do updates, to do cleaning on the data, whatever stability stuff we need to do, that includes that. So 4 minutes a month, counting any of that downtime that we need to do for maintenance. ML-driven management and configuration. So AlloyDB includes some cool machine learning. Now, we're not talking about like the Duet AI stuff that you've been hearing all over the conference. This happened before the mad rush on this. ML-driven management configuration is things like, with Postgres, one of the biggest hits that can happen to your database is when do you clean it? When you do that vacuuming, when you actually delete the data that you've marked for delete. One of the cool things about AlloyDB we've included is this vacuum management, where we will figure out, based on your workload pattern, based on your, like, when the intense workloads are coming in, when to do that cleanup for you. You don't have to manage it anymore. We can do that for you, so we figure out the best time to do it so it doesn't impact. We have storage and memory disaggregation. So your compute, your processing, and the storage itself are separate in AlloyDB. So both of them scale independently, so we can help manage the optimal use of either storage or your memory to make sure that we are getting the best bang for your buck out of your instance. And then last, we've got data tiering. Does anyone know what data tiering means? So data tiering is putting the data based on your usage. So into the fastest part of your either memory, storage, cold storage. So we arrange the most used data in the place where it's going to be accessed the fastest. So we have the part of the machine learning is to figure out which data goes where. So that's what that one is. Then we've got transparent and predictable pricing. Again, remember, I stole these from most of our sales guys. This means that we are very clear about where the pricing comes from. We don't have any hidden charges. The price is what the price is. You've got your ingress and egress charging. So if you can figure out how much data you've got, where it's moving to, and how much processing power you need, it's very clear how much this is going to cost. It's not going to like surprise you with hidden charges anywhere. So that's what that one is. So having said that, now we have a handle on the managed version of AlloyDB. Take all of that, stick it in a couple of containers, and now you can deploy it anywhere. I think of AlloyDB kind of like the Where's Waldo of cloud databases. You can kind of find it anywhere, but you don't really know where to find it because it's not connected to the cloud when you do it. And of course, now I probably lost you all because you're all looking for Waldo, aren't you? Let me help. I've got more if you really want to do Where's Waldo. We can do more of those later. So now I would like to hand it off to Kevin to go into a little more detail about AlloyDB Omni.
Thanks, Gabe. This is supposed to be a container, by the way, on this slide. And AlloyDB lives inside a container. When you download it, you're actually downloading a Docker container with the AlloyDB engine in it. We actually have a little component in a separate container that manages the memory, but basically you're downloading a Docker container. So this is how it comes. But then the question is, what environments does it run on? And so, we support, there we go, we support a whole bunch of environments, certain flavors of Linux, Red Hat, Ubuntu, Debian. And then we also support running in various clouds, not just on premises, not just in a server that you manage. You can also run it, obviously, in Google Cloud, in your own GCE instance. You can run it in AWS. You're going to see some live action on AWS in a minute. You can run it in Azure. You can run it in probably pretty much any cloud. Your private cloud, your data center. You can run it on a laptop. So, and we will have a demo on the laptop in a little bit, too. So it only really needs 2 gig of memory, 2 CPUs, and 20 gig of storage to get started. So if you have a laptop with that much capabilities, you can run it there, or pick a server running in a cloud environment for that. So it runs anywhere, packaged in a downloadable container, and again, you can put it almost anywhere, but it has all the same capabilities that you just heard about in AlloyDB Cloud, with a couple exceptions, because AlloyDB Omni does not have the separation of compute and storage. So you don't get the benefits of that, the extra performance and other capabilities of separating compute and storage. And of course, it doesn't have a control plane. It's managed by you. It's not managed by us. So you'll have to figure out, and I'll talk about this more in a minute, you'll have to figure out how to set up HA and backups and replication. We're going to give you a bunch of help on how to do that. Having said that, it still scales really high. It scales much better than stock Postgres, because a lot of the improvements we made in AlloyDB were to the core Postgres engine for high concurrency scalable workloads on larger servers with lots of CPUs. AlloyDB Omni still scales really well. It scales about half as high as AlloyDB in the cloud. And it's got a bunch of intelligence built in, like I talked about, like Gabe talked about, to manage things like vacuum and memory and other things. So up to 2 times the throughput of stock Postgres. We see that result, those performance results, in transactional benchmarks. So we see these kinds of results when you have high concurrency and small transactions, which is typical of a lot of workloads. And I actually say up to 2, it's actually more than 2x. The bigger the machine, the more CPUs, the further it pulls away from stock Postgres, because stock Postgres flatlines at somewhere between 12 and 16 CPUs. You can give it 32 or 64, it won't go faster. So we're actually more than 2x, and AlloyDB Cloud is more than 4x at the high end. Oops, went the wrong way.
It's broken.
Uh-oh.
There we go.
There it is again.
Yeah, AlloyDB Omni includes the columnar engine. It works exactly the same way as it does in the cloud. It's the same code, same capabilities. Gives you up to 100x performance improvements or more, and depends on the query and the data and all that. But that's all exactly the same as it runs in the cloud, because the columnar engine doesn't depend on separation of compute and storage. You get a bunch of stuff in the special columnar format in memory, and then the queries will run much faster. So if you have the same CPU, same amount of memory, same data, same queries, they'll run exactly, they'll get the same performance improvements, whether it's AlloyDB Cloud or AlloyDB Omni. There. And it has all the same ML-driven management built in. Adaptive vacuum management, adaptive memory management. It also will automatically move data into the columnar format based upon your query patterns, your workload pattern. And it will also, we also have the index advisor. So it will actually watch your query patterns, look at your data, and suggest indexes that you might want to add or take away from your tables. We're not going to talk much about pricing today. We are planning to announce pricing soon. The focus is going to be very similar to what you see with AlloyDB in the cloud. Make it transparent, predictable, easy to understand, and affordable. When we launched originally back in late March, we made a commitment that our pricing would be a fraction of the cost of legacy databases, and that's not going to change. When we actually announce the pricing, you'll see where that fits. So this slide is a good comparison of AlloyDB in the cloud, the leftmost column, AlloyDB Omni, and self-managed Postgres. So I'm not going to go through everything on this slide, but you can see the performance differences in terms of throughput differences. The 4x and 2x should actually be more than 4x and more than 2x. The analytics performance is the same for both AlloyDB versions because it's the same columnar engine capability. They both have the autopilot capabilities, all the ML-driven automatic management. And SLA is kind of important to understand. As Gabe pointed out, this is a product that you manage. So it's not a service that we can give you an SLA for. So I'm going to talk a little bit about how we're helping you with that, and we're going to give you more help over time. But it's still a product that you're going to install and manage in your infrastructure. And the same thing for the backups and replication, et cetera. We're going to help you in setting all that up, but it's still your job to actually set up and monitor and manage your backups and replication and your HA and DR setups. And then finally, support. We will be providing standard Google support, all the way up to Google Premium support, depending upon what level you've signed up for your AlloyDB installations. It's obviously going to be a bit different since we're not in, you're not running in our infrastructure where you can see things happening. So it's going to be a different support experience only because you'll have to reach out to us and give us information on your environments and all that. But we are going to provide the same level of support over time as we do for our on-prem, for our cloud-based services. All right, I went the wrong way again.
Down is up.
Yes, down is up is down. So let's talk about common use cases. And so the first use case that we've heard from customers, because you might be wondering, why did we do Omni in the first place? You know, we have this great cloud service. Why are we doing this thing that isn't in the cloud? And really, the first use case is customers who have a big fleet of legacy databases on premises, 5,000 Oracle databases, 10,000 SQL Server databases. They want to move off of those databases, but they're not ready to move to the cloud. So they can't get to the goodness of AlloyDB in the cloud. But they want to move off, and they're not ready to get to the cloud. So we're trying to give them basically an enterprise-grade Postgres with enterprise-grade support. And that's really where AlloyDB Omni fits, is in that space where customers have workloads that aren't ready for the cloud, but are ready for a higher-end Postgres. So I'm going to hand it off to Simon, because he's going to do our first demo of the day.
All right. Thanks, Kevin. And can we switch, please, at the back to the demo computer? So I get all the excitement here because I'm going to do some live demos. And I'm actually doing them all live. I'm going to do some in Google Cloud here, and then later in AWS. So I'm actually going to just open up. This is my own personal Google Cloud account. You guys can turn to each other now and make bets as to whether the demos are going to fail or not. I like to live on the edge with live demos. And I'm actually going to paste in a command really quickly to start it off because it takes 2 minutes to run, and then I'm going to explain what exactly is happening in my command. So here's my command. I'm going to try to copy it. I'm going to try and paste it here into my Cloud Shell. First thing went and worked. Oh, close to working, and there we go. So what am I doing here? Well, what I'm doing is a really quick start to get AlloyDB Omni up and running. So I first started it using it about 6 months ago. When did the first preview come out?
March 29th.
March 29th, okay. And even seasoned DBAs sometimes are a little bit confused about the whole container aspect and running in Docker containers. And really, what I want to emphasize is it's really simple to get started. The reason I wanted to paste the command here is because it takes about 2 minutes end to end. And I think that's pretty impressive that we're going to go from nothing.
2 minutes.
Oh, that wasn't 2 minutes? Well, that's only because all we did so far is provision some cloud infrastructure. So if we hit refresh, what I did here is I just used a Google Cloud API command, the gcloud command, to provision a virtual machine. And you don't have to do this in Google Cloud. You could do this on premises using VMware. I do it using Kickstart files and things like that. I just provisioned some very simple infrastructure. And then I just went to the AlloyDB Quick Start documentation here. And you can go here, and there's some very simple steps. So if anybody in your organization or you personally are not very familiar with Docker and containers, and it adds a little bit of a level of fear, uncertainty, and doubt, it's very easy to get past that. All I've done is really take all these very simple commands, I copied and pasted them into a startup script. And really, that's what I did in my command over here. Let me just switch back to the other tab. Is really, all I did is created a new VM, and I passed into there a name of a startup script, and it was running. So yes, as Gabe pointed out, the machine coming up happened very quickly because Google provisions the infrastructure very quickly. And now I can connect to it, and what's happening in the background is all I did was cut and paste those commands, as I said, into a startup script, and it's going to install Docker for me, download the container, and really get everything up and ready to go. So now we just wait a little bit as we connect to the terminal. And this is a nice part about Google Cloud, by the way, the fact that you don't have to have a terminal client. You could just SSH in directly from the Cloud Console. And how long has it been? Has it been 2 minutes?
I don't know, let's find out.
Oh, yeah, it has been. It's all done. So what I see here is that it's downloaded, and it's got an installation directory. It's called a data directory. It's also created, and it's done. And I actually augmented the instructions a little bit to build myself my own little README file. And if I take a look at my README, I give myself some quick notes of how I can connect. And I can just highlight that and paste, and there we go. Ta-da, I'm into Omni already. So that was less than a couple minutes, and I went from 0 to having everything provisioned. And again, I'd like to emphasize you don't have to do this in Google Cloud using G-Cloud commands. There's lots of other ways where you can do something very similar to spin it up really quickly for your devs.
And each iteration, this is getting easier and easier to do. So
Exactly.
like the tech preview was a little funky. You had to run the Docker commands to get the stuff. This is now the next level. These instructions include with it now a command line tool that lets you just do server install, and it does it. And it'll keep getting easier as we iterate.
So on that, I'll turn it back over to you until later on.
Yeah. And yeah, like Gabe was saying, one of the things we launched yesterday is a CLI.
Do you want to switch, please, to the
we can
slides?
switch back to the slides. Thanks. So now there's a CLI to make everything that Simon just showed you even easier. Because he had to type in a lot of stuff into scripts, and now you can just use the CLI commands, and it's a lot less effort and less complexity. And that's all documented in the doc update we dropped yesterday. So what's our next use case? Well, it's on the edge. And what do we really mean by edge? There's kind of a bunch of sub-use cases here. So we have, for example, telcos. Telcos need to have databases very, very close to their customers in a lot of cases. They install racks and closets on company premises because they need real low latency for the users using those databases. They've been doing this for years. And they've been doing it with legacy expensive databases, and they want to move to an enterprise Postgres with enterprise support. So AlloyDB Omni is a really good fit for that use case. Another use case is what we loosely call retail edge. So there's lots of retailers out there with lots of stores, and they've been running databases in their stores for years for similar reasons. They need the stores to keep running even when they lose connectivity to the internet, so they all run local databases everywhere. And they're never going to move those to the cloud, because they just need to stay up and running even when there's a flood and they lose connectivity but still have a local generator to keep the power on in the store. That's an example that we've been given several times. And other examples that aren't even on the slide that came up more recently, manufacturing on the factory floor. They run databases on the floor because they can't afford to have the assembly line stop when they lose connectivity. So there's a lot of use cases like that where customers want a database that runs locally, truly locally. They cannot move those to the cloud. And so I'm going to hand it off to Gabe now for another demo.
Back to the demo laptop, please. So the business use cases on the edge are great, but what if I just want to use it on the edge? Or what if I'm at Moscone yesterday and my internet goes completely kaput, and
what if I
would like to continue using a database?
And what if you're a developer who just, yeah.
So what I would like to show you now is I have, I'll make sure it's still kind of going here, on my laptop in a virtual environment, I have installed AlloyDB Omni, similarly to what Simon had showed us, all of the steps. So now I have it running locally. So I want to show you real quick. I have the 192, so you know that this is local. And I would not create all of these tables of my own volition. So you know this is AlloyDB Omni because it has all of the tables built for you. So this is now running locally on my laptop, and I have a little script here that is, I call it the faker script. It generates a fake data set of employees at a company. So just to show you, like right now, I've got 13, 14 rows, 13, 18. So the script that I just fired is currently adding rows to my database. So what I'm going to do now, I'm going to make sure I'm going to pull the correct thing. I'm going to disconnect my internet. I have just pulled the cable off the cord, and to show you, if I try and go somewhere, I have no internet. But you'll notice, I'm still running against the database. And if I can get back to it, it's still adding rows to my database. So there's nothing connected about AlloyDB Omni. It's running completely locally. There's no internet. It's only on my laptop. So no matter where you are, even if you become disconnected, you can run against AlloyDB Omni. Back to slides, please, and I'll hand it back to Kevin.
Yeah. And just one point on that. Yeah, there's no connectivity. There's no phone home built into AlloyDB Omni today. We do plan to add capabilities over time that will make it useful for you to connect back to Google Cloud. In fact, in the public preview, we've already added support for connecting your AlloyDB Omni instance with Vertex AI. So you can actually connect it back into the cloud and use Vertex for inference and other fun stuff. Can we switch back to the slides, please? All right, so the third use case we want to talk about is multi-cloud. Got lots of customers who have lots of workloads running in multiple clouds. They either built different application stacks in different clouds because they needed certain special capabilities only available in that cloud, or they acquired companies over time with different stacks in different clouds, and they want a common database running in all these clouds. And they want a common database that has the capabilities that AlloyDB Omni has. And so they can have one standard way to support all of these workloads. And so Omni runs the same way on all these different clouds. It's the same code. It's the same Postgres compatibility. It's the same columnar engine. It's the same scalability. It's the same autopilot capabilities. It's the same everywhere. And so that's been really appealing to a lot of customers we've talked to. And so now Simon's going to give us another fun demo.
Yeah,
he needs,
sure.
He needs to run through some slides
Did
first.
you notice my colleague almost sabotaged me there because he forgot to plug the
forgot to
internet
plug
back
it
in?
I know. It works fine without internet.
Not the AWS demo part.
Fair enough.
Right? So it doesn't work without internet. So luckily I caught that. So as partners, we're asked to do all sorts of things like moves, migrations to the cloud, and understanding how helping customers understand how they can leverage new features or increase performance. So what I wanted to do now is set up a more complicated and interesting demo where I'm going to simulate running AlloyDB Omni and Aurora in AWS. So what I want to show is that really this is easy. Okay, we don't need to do anything special. We can install Omni right into an EC2 instance in AWS, just like I did in Google Cloud on a virtual machine there. And the reason we might want to do this is to test some of the unique features that AlloyDB brings. So this is a diagram I drew, which I think will help everybody understand what I'm about to do when I go to the terminal screen. So really, my architecture is this. I have one EC2 instance, and I'm about to terminal into it if the internet came back after Gabe's demo there.
I tested it. It's good. It's there.
You tested it? Okay, because if the internet doesn't come back, it's not going to be a very good demo. So I'm going to terminal into that one EC2 instance where AlloyDB Omni is already running. That's my local database. And then I'm going to also connect to an Amazon Aurora, which I created earlier. And I'm going to actually simulate some data coming across and testing some of the new features of AlloyDB Omni. So I'm trying to make a very realistic use case. And I didn't want to use just the standard PG bench data, which is very artificial and everybody knows and maybe some people like. So another colleague at a totally different presentation used this thing called the Chicago Data Portal, because he was from Chicago, I'm not. But I love Chicago. I was just in Chicago, and it's a fantastic city. But they expose a very large data set, all sorts of different things. And what I did to prepare this demo is I just looked for business licenses, and I've downloaded the business licenses table, and I downloaded it the other day. It's constantly being updated. and I put it into my Aurora database. And the use case I'm trying to simulate here is maybe somebody's opening a new business and they want to run a query to say how many other new businesses opened in the last 90 days in my zip code. Now, sure, that's not necessarily an analytic query, but still, I'm going to turn on the columnar engine afterwards and we can see some of the advantages. So can we switch to the demo computer now, please? All right, so let's see if the internet truly is back. Otherwise, it won't be too much of a demo. All right, it's back. So as you can see, this green prompt is that EC2 Amazon database that I showed in the illustration a second ago. And what I can do here is I can connect, and I'll first show that I have Omni installed locally. So whenever I connect and I use localhost, I've connected. I've pre-created a database called Chicago because that's where my table is going to be in the Chicago data set. Now, Gabe showed us all the tables there, and he said he didn't, somebody's not going to emulate having all those tables or views and things like that to convince you that we're really running against Omni. I'm a little bit more trusting, so I would usually, when I connect, just look at what users exist. And I can see there's an AlloyDB admin user and a replica user, or I can look at what default databases exist, and we can see, again, we got AlloyDB admin. So hopefully from that, that's good proof that whenever I connect and I use localhost, I'm connecting to Omni. Now, the other thing, too, as I said, is I have an Aurora instance. Now, AWS gives you very big, long endpoint names. So to make things a little bit simpler for myself, I just put that in a variable. Yeah. So there's the Aurora endpoint, but I can connect to it by just using this variable. So let's just test that, make sure that works as well. $Aurora. And again, I'll use the same techniques. If I look here and I look at the users, I can see I have RDS admin and replication and so forth. Or I can look at the databases and I can see that there's an RDS one. So hopefully I convinced you that whenever I connect with the Aurora, I'm connecting with the $Aurora variable, I'm connecting to the Aurora instance. And when I connect as localhost, I'm not. I'm connecting to Omni. So let's just go into my scripts directory here. And the first thing I want to show is I loaded this table, and I loaded it in the 11 million or so rows. And let's just do a quick query on the Aurora side and see how many rows are actually there. Should have given a variable that was a little bit easier to type, like just $A, maybe. There we go. Okay, so we have a nice, easy number to remember. It's 3 ones, and it ends with 88. That's how many are on the Aurora side. Now, let's see. Have I created my table even on the AlloyDB side or just the database? Well, we can just change this, connect to the Omni side, and take a look. Nope, the table doesn't exist. So what I have running in Aurora is I have logical replication through PG Logical. And if you don't know Postgres replication, that's all right. That's not really necessary for this demo. Just understand that Postgres can provide logical replication in near real time to any number of targets. So in this case, I've pre-configured that on the Aurora database. Now, to start the replication, I need to actually create the empty table here on the AlloyDB Omni side. So let's just do that. Let's just create the table. Voila. And now let's just test again. The table exists and it has 0 rows. So all I have to do to start copying through replication some of my live data that might be in my AWS Aurora into my AlloyDB Omni, because I want to experiment there, is just create a PG logical subscription. So first of all, I might want to just test in Aurora and make sure my table has been added to my replication set. That's just the list of what tables are going to be replicating. And of course, in a real use case, you're going to have tons of different tables. But for me, I just have this one, business licenses, that I downloaded. And all I'm going to do is simply add it to a subscription on the Omni side. So let's do that. We'll just say, great, subscription. And this is a good time to bet with your neighbor if demos are going to fail or not. Okay, so we created a subscription. And now let's just see if the rows came across. Might take a second or two, so we do a count right now, and it's 0. So now everybody hold your breath. If I do it again, is the data there? No, not looking good for the demos. Oh, phew. There we go. A little bit worried there that it took a second. And is it replicating just once, or is it doing it in real time? Well, we can go and we can add a row back. So actually, let's just connect in PSQL and manually add a row. So if I just describe business licenses, again, I should have picked a table. It was easier to type. I think there's only 2 mandatory columns, but I can't seem to scroll up, but that's all right. Insert into business licenses, ID and license ID, values, and we'll just call this demo, and 9876. Okay, so we inserted 1 row. Let's double check we're on Aurora here. Yes, see the RDS users, we're on Aurora. And again, if we check now against Omni, yes, you see we're up to 10, ends with 89. So the row came across. So that's all good. So I just showed that it's very easy to copy your data in near real time from Aurora to Omni. But why would we want to do that? Well, we might want to test some of the new features, right? So let's say I have this query that I mentioned. I want to know what businesses opened in my zip code in the last 90 days. And, oops. Okay, so there's this query, and I just want to do an explain on that to see what the performance is. So first, let me connect to Aurora and make a baseline. Explain query. Okay, so that told me down the very bottom here that the execution time was 266 milliseconds. That's pretty quick, but this is just for demo purposes. Maybe in your real environment, it's an order or 2 orders or 3 orders of magnitude more. And let's run it a couple times, right, just so that we can warm up caches and stuff. This time a little higher, 353, 292, 266. So we get an idea. It's close to 300 or the high 200s. So the first thing I want to do is try the same test against Omni. So let's connect to localhost. And let's do the explain. All right, so we got something pretty similar. Well, we expect it to be kind of similar because the size and shape of my Aurora and my EC2 are the same size, but there's probably other differences. But we're getting in the same kind of ballpark, around the 300 milliseconds. So the last thing I might want to do is enable the columnar engine and see what kind of difference that makes. So to do that, I just have an add CE script. And it only takes 10 seconds here. It's going to show you what I did. All I did is I said I want to mark this table to load it into columnar memory as well. I said 10 seconds. There we go. 10 seconds, almost 11. And now let's just rerun the query and see what the difference is. Right? 7, right? So you see I dropped from 300 milliseconds to 7 milliseconds. Let's do it a couple times just to make sure it's consistent. You see 6.8. 6.9, 6.7. So end result there is, sure, there's lots of different ways you can tune a query. You could add indexes, you could restructure it. But if you have a packaged app, maybe you can't do all of those things. So I just wanted to experiment here and show that by just enabling the columnar engine and loading this one table into columnar memory and not doing anything else, I seem to have gotten about a 40 times increase in performance. So there you go. The demos all worked, even though I was almost sabotaged.
Sorry.
If we go back to the slides, please. Yeah, and a couple key points about that demo. Simon didn't even, do it efficiently because he loaded the entire table, all the columns, into the columnar engine. He only really needed the columns that were in his query to speed up the query. So he could have gotten more precise. But really, the right way to do this at scale is to turn on the automatic management of the data driven by ML. Looking at your query patterns, looking at your data, it will automatically put the right columns in memory for you.
So come back next year and the demo will be improved.
Right.
Yeah, well, yeah. So there's more to it, and he could have turned all that on. It just takes a little while for that engine to learn your query patterns and then start loading data. So to do a demo, we usually have to force the data in early. Let's move some slides. Okay, so I want to talk a little bit about support and partners. I mentioned earlier that we are going to provide full support once we're GA. But to go from tech preview to public preview, what we've also done is in addition to continuing to support AlloyDB Omni on our Discord server, which a lot of that is Gabe and his team, answering your questions on the #Cloud Databases channel in Discord, we also will respond to support cases. So if you have a support account and you file a support case about a question or issue with AlloyDB Omni, we'll do a best effort response. We're not following support SLOs yet because it's public preview, it's not a supported product. But we will do our best effort to start helping customers from support. And then partners. We have, in addition to Pythian, and they're a great partner, we've got a whole bunch of launch partners, AlloyDB Omni public preview launch partners, who have ramped up on how to help customers with AlloyDB Omni, how to help you with POCs and testing and moving workloads. And Pythian's, of course, right there on the slide, but there's a big world out there, and there's a lot of partners and a lot of customers need help. So I just want to say, hey, these are the partners who are ready when you have questions about what you can do with AlloyDB Omni. And then other things we've added. We've added Postgres 15.2. When we launched the tech preview in March, it was still 14.4. We moved it to 15.2, and when we go GA, we will just support 15.2. We're not going to support the old Postgres 14 version at all. This matters to some people who pay close attention to what the Postgres community adds in the new major version. So from 14 to 15, they've added a bunch of new cool stuff. That's all available in Omni, since it is 100% Postgres compatible. And then, I mentioned this earlier, just yesterday morning, we published a set of detailed technical guides on how to implement various data protection scenarios, how to do backups, how to turn on replication like you saw Simon do, but turn on replication for more complex use cases like HA and failover and DR. So there's a bunch of detailed guides, which once we go GA, we will provide full support for those guides as well. Those guides do depend on open source tools and features. We'll be fully supporting any problems you might run into with all of those capabilities. And then we've also added support for our enhanced PG vector and integration with Vertex AI. And you probably have heard a lot about these, especially if you saw the AlloyDB session yesterday or Andy Gutman's Spotlight session. These are in AlloyDB Omni and, of course, in AlloyDB Cloud as well. So you can build Gen AI apps right now on AlloyDB Omni on your laptop. If it's connected to the cloud, you can use Vertex AI as well, but you can use PG Vector even on your laptop disconnected. And one thing that isn't on this slide, we also just yesterday launched a separate tech preview. So it's an earlier stage preview of AlloyDB Omni with local embedded models. So it's kind of like working with Vertex AI, but you don't need to call Vertex AI. There's a couple models we've embedded in the local download of Omni, so you can actually test those capabilities without even being connected to the cloud. And like I said, we're not going to talk much about pricing other than we're sticking to what we committed to back in March. Going to make it simple, transparent, affordable, and we will continue to have a free developer edition. So that is available now, and it will continue to be available when we go GA. Now I'm going to hand it back off to Simon.
Yeah, and lastly, if you're just starting out and your organization is interested in getting going with Postgres in Google Cloud, we offer a free, no cost to you, one-day workshop where somebody like myself can work with your technical teams, either remotely or on-site, to go through your migration journey. It's kind of the opposite of here we're all coming to San Francisco and getting sessions. This is the opposite, where all the sessions come to you, including a lot of hands-on labs and actual hands-on keyboard stuff and collaborating and brainstorming on migration paths. So if that's of interest to you and you're just starting your journey, reach out to us and we could maybe arrange to do a free workshop.
And to that end, the first thing that we want you to do is go try it. Grab it, it's easy to use. Just go to that quick start page, get started, download it, and play around with it. During this public preview right now, before we're talking about pricing, it's free to use. So get it, play with it, kick the tires, give us feedback, and let us know what you like, what you don't like, so we can make improvements as we go. The last bit before they kick us out, please do the feedback on the session in the app. Go through, let us know what you liked, what you didn't like. If you want better sessions next year, this is the way to get them. And with that, thank you very much for coming for our session. We are out of time, but we'll meet you outside to chat if you want.